I'm Noah Lugameno, project manager and educator for Teachers in Space. We had been planning on doing a how-to balloon mission this morning, but as is the case often with space flights and flights of any kind, weather was not conducive for a launch. So we decided to instead provide this training that involves going over the details of planning and flying a how-to balloon mission with a payload on board. So our intention was to fly this morning 5 CubeSats from students made from classrooms from around the country. We decided that because a storm was coming in, we didn't want to potentially lose those payloads. So we will instead aim to do that same mission in a week's time. Next Saturday is what we're aiming for now, of course, weather depending. When we do these missions, we use some very freely available resources in order to do the actual planning itself. So I'm going to go over some of those resources and help you get yourself on the way to being able to conduct one of these missions yourself. Let's start by talking about the various supplies that you'll need to do a high altitude balloon mission. So starting off, you'll need a balloon. We generally use a 1200 gram balloon with a 3 centimeter neck, a 1.5 meter parachute, and an APRS tracker. You can find pretty much all of these items at highaltitudescience.com. If you go to their products, here you can see we've got various balloons. There's the parachute, and here's the tracker. Now, the one thing to keep in mind is that they don't always have everything in stock, so try to purchase all your supplies well in advance of when you plan on doing the mission. Next, you're going to need to be able to inflate your balloon. So that's going to require some helium, as well as a regulator and some hose and fittings, and a piece of PVC pipe. If you look on High Altitude Science, they have pretty much this exact setup right here. And this is one option you can go, but you could also make a DIY setup as well. We generally will get a K tank of helium, which contains about 200 cubic feet of helium. And you can usually get them at your local welding supply. For the payload train, you need a line. Again, High Altitude Science has flight train kits, which include that line as well as a swivel, so that as the balloon spins, the payload doesn't have to spin quite as much. Optional items are a 3-point harness, which will just give you more points to attach the line to your payload container, and a camera. I use a 360-degree action camera because it allows me to edit the video to be able to look at in any direction during the flight. If you want a more accurate view, you might not want to use one of those cameras because they use fisheye lenses in order to get that 360-degree view, and so it introduces a lot more curvature into the shots depending on where it's focusing. So it doesn't give you a accurate representation of the curvature of the Earth and whatnot. But if you do that, you would most likely need to use multiple cameras, which can increase weight and cost. So it's a trade-off between accuracy and being able to get some good shots. Additional supplies, a fish scale can be used to help determine how much lifting weight your balloon is exerting. You would tie off your balloon and then you would attach it to the fish scale and then attach the other end of the scale to a stationary object, or you would hold it, and then the amount of force that the balloon is pulling with will be shown on the scale. We next have a tarp. It's important when you are inflating the balloon, you're going to lay it down on a nice clean tarp first to avoid it making contact with the ground and any potential debris that could damage the balloon in any way. Then once the balloon is filled, you will remove the inflator while holding it tight and pinching it shut with your hands, and then you're going to fold the neck of the balloon up and wrap it and cinch it tight with zip ties. You know, 3 or 4 zip ties should do it. And then you're going to cut the ends off those zip ties so that they don't poke into the balloon. And you're going to wrap it all up in duct tape. We also use zip ties in wrapped around that fold in the neck of the balloon to create a loop that we can then attach our payload line to. While we're handling the balloon, we always wear gloves so as to not get the oils from our hands on the balloon, which could damage the structural integrity of the balloon as well. And then finally, we bring a handheld amateur radio with us to be able to pick up the signal coming from the APRS tracker to ensure that it's actually transmitting. Once you have all the materials for your flight, you're going to then want to start doing some predictions. So if you come to highaltitudescience.com and you go to the tutorial section, at the bottom is balloon performance. This is a tutorial on how to use their balloon performance calculator. And then if you click on this link right here, it'll bring you to the calculator itself. So if we plug in a few items into the left side input here, it'll give us some important information that we'll need to use to run a prediction on the right in the output. So we're going to use a 1,200 gram balloon. Our payload weight is going to be 2,500 grams. And for positive lift, we're just going to guess a number to begin with, and then we'll adjust that number if we need to for our prediction. So then we click calculate, and what this is telling us is that with this balloon and this payload weight, we would need to fill it with 169 cubic feet of helium. Now, a K tank of helium generally holds about 200 cubic feet. So with this set of parameters, our balloon would reach a burst altitude of about 29,260 meters and have an average ascent rate of 4.31 meters per second, which would give us an ascent time of about 113 minutes. So if we plug these numbers into our predictor, it'll give us a good idea of where our balloon is going to land. So if you come to predict.sondhub.org, this is the resource that I generally use to do these predictions. What you're going to want to do is choose your location where you're going to launch from. And this might change a little bit depending on conditions, but you generally want to have a location that is pretty wide open, like a park or a large parking lot, and doesn't have too many tall structures that the balloon could get stuck on. So you want to avoid being near power lines or telephone wires or trees. So we were going to run a mission this morning, as a matter of fact, but then the weather kind of turned on us, and we were going to launch from this park right here, just northeast of Syracuse, New York. So to set our launch location, you click Set with Map, and then you click on the location. That gives you a little bullseye right there. And then we have to fill in the launch altitude. This location is about 200 meters above sea level. You're going to want to put in your launch time in UTC. So that's like about 4 hours ahead. And if we wanted to do this early in the morning, which is generally the best time because the surface winds will be lower at that point, and it'll blow your balloon around less when you're trying to inflate it. So let's see what happens if we put in 10 UTC, and let's go with tomorrow. And then our ascent rate, we look at our performance calculator, was 4.31. And our burst altitude was 29,260. And then for our descent rate, if we go back to the parachute on High Altitude Science, this 1.5 meter that we're using, it actually says what some of the landing speeds are depending on your weight. So now we're doing 2.5 kilograms, so that would be a 6.3 meters per second landing rate. for descent rate, 6.3. All right, and then we're going to run that prediction, see what happens. So here's our launch location. The balloon travels to this point right here where it reaches its maximum altitude and it's most likely to burst. And then it comes down on the parachute and it's going to land right smack dab in the Hudson River, which would not be ideal. We generally want to stay away from large bodies of water or highly populated areas like cities. So let's adjust the performance a little bit. So we have more helium to work with. We could fill this up more. So what happens if we wanted a 2,000 gram lift? That would be a little bit too much. That'd be over the 200 cubic feet that we have in our K tank. So let's drop it down to 1,800. That's 197. That would be basically the entire tank. So that changes our burst altitude and our average ascent rate. So we'll change those. So 220 for the altitude. And we'll call it 5.5 for the ascent rate. And we'll run that prediction. That seems a little bit better. It's not near any big bodies of water. If we start investigating this particular area with the Esri satellite, you can see that it's a mix of farm fields and wooded areas. This isn't the most ideal location. It would be better if it was more fields. And also, you can see right here, these lines are power lines, big power lines, and you definitely don't want to have your payload land on those. So if this is the case, you would go through and you would manipulate these numbers using your balloon performance calculator, changing those parameters and seeing where your landing could possibly be. It might turn out that you just need to either choose a new starting location or you need to choose a different day. Once you have your flight in the air, you're going to want to track it. And so we include an APRS tracker on all of our flights. APRS is Automated Packet Reporting System, and what that tracker does is it's constantly sending out signals. Well, every so many seconds it'll send out a signal with its location, and there are repeater stations all around the country that pick up those signals and then upload them directly to this website. So if you type in your call sign right here, for instance mine is KD2UJJ, you can then search and find your payload. So this was from a flight that we did in the summer of 2024 in Las Cruces, New Mexico. And we did it from Las Cruces International Airport, which is actually a relatively small airport at the New Mexico State University's unmanned aerial vehicle testing site. They have a wonderful hangar here with lots of drones and such, and they allowed us to fill up inside their hangar and launch the balloon right outside of it, which was a really amazing way to do things. If you can inflate your balloon inside, that is the best situation, because then you don't have to worry about the wind, blowing the balloon around when you're trying to fill it up. So we released from here, and if you look at the altitude, it's already starting at a pretty high altitude because, number one, that was just the topography of the region was up higher than sea level, but also the first signal from the tracker doesn't reach any of the surrounding stations until it was at least 4,836 feet up. So if you look at each of these little red dots, it'll give you information, because that's where the tracker had sent out the next signal. So at this point, so this is at 9:31, it was at 14,652. The next signal was at 9:32, and it was at 15,955 feet. It also gives you the heading and the speed. So eventually one of these dots is going to show the maximum altitude that the balloon reached. And so we can kind of figure that out. So this one here is 87,218. See the next one if it's still increasing. Yep, so it's still going up. It's at 88,000 there. 93,000 there. Oh, and 89. So this was the highest point that the tracker received or was able to send out data, was at 93,744 feet. It may have gone up a little bit more before it actually burst, but by the time it sent out its next signal, it was already on its way down again. And so you can see an interesting thing here. You see these two little changes in direction. I wonder if those are at similar altitudes. So that's 51,052 feet. And that's 51,265 feet. So at that altitude, apparently on this day, in this area, there was a crosswind that was going on. So as the balloon passed through it on the way up and again on the way down, you can see that the direction that the balloon is traveling changes. And then eventually we finally landed over here. And so this was just the last signal again. After 5,705 feet, the next signals that were sent by the tracker, it was too low to the ground for it to reach the nearest station. So this is not going to be exact. It could be anywhere within, half mile or a mile of that location. So you can see here that it landed right next to this county road B044. In reality, that road barely even exists. Most of these roads in this area were in the middle of the desert for the most part. So while it looks like there's a lot of roads here, there actually were not very many. But we were lucky enough to be able to get out of the truck after doing a little bit of off-roading, and we walked around for maybe 15 minutes or so, and we were able to find the payload. So that was awesome. So yeah, this is essentially the process that you would use in order to go ahead and plan, launch, and track the balloon. When it comes to recovery, it's not always guaranteed that you're going to be able to find your payload, but the more planning you put into it, the more likely you are to get your payload back. And that's really important, especially for our payloads with our CubeSats, because we have all of our data being collected directly onto micro SD cards that are in the CubeSats. So we want to recover them and be able to collect that data. Another very useful feature here is the Google Earth KML. You're able to download a file that then can be imported into Google Earth, and I'll show you what that looks like. Let's take a look at that mission. We actually have the video of that mission. If you go to our website, you can go to News Media and click on videos. That'll take you to our YouTube page. And if you click on videos and you search for this Teachers in Space High Altitude Balloon Mission on 7/16/2024, that'll bring you there. So this was the mission that we conducted as part of our summer workshop series in New Mexico in 2024. We trained 60 teachers to build CubeSats, and then during those workshops we actually conducted 2 balloon missions. This one was the more successful of the 2. It reached a higher altitude. So here's just a rundown of the balloon payload train, various parts to it. This is the payload container, 3D printed container. And let's pause this real quick. So this is the payload container in the hangar. It has the camera on top as well as a backup tracker. I would maybe forego this type of 3D printed container in the future just because it added so much weight. We would be able to fit more payload, use less gas if we didn't use such a heavy compartment. In the background, you can see the parachute on the ground there, and then this is just prior to actually inflating the balloon. So here is that flight path that we looked at on aprs.fi. And this right here is what I was talking about, where if you download that KML file from aprs.fi, you can load it into Google Earth, and then it'll show you three-dimensionally what your flight path looked like. So you can see right here, this was the maximum altitude before it started coming back down. I'm just going to lower the volume. So on this particular flight, we had a beacon buzzer to make it easier to hopefully find the payload once it was down on the ground. That's another thing I might forego in the future. I don't know that it necessarily helped us. You can see he just released a test balloon just to make sure there were no extreme winds right down at the surface that would have blown our balloon into the hangar or something. And so after we confirmed that there were no airplanes in the area, we then got ready to release the balloon. Now you want to be careful when you release. You want the balloon to pull the payload and the other items in the train out of your hands. You don't want to drop them or throw them. You want the balloon to do all of the work. And so here you're seeing various views from that 360 action cam. You can see how the fisheye lens kind of distorts the view a bit. So some people try to avoid that by using multiple regular cameras instead of one of those 360-degree cameras. In this video, in the description, are timestamps for various events during this flight. So feel free to skip through it. You know, once we start really gaining altitude, you get some really spectacular views. There's also some interesting sounds. You hear the howling of the wind. So do go through this. Here's the balloon burst. This is particularly interesting looking, I think. So you can see the remnants of the balloon up there. It's made out of a biodegradable latex, so you don't have to worry about polluting. And right now at this point in the flight, the balloon is really just free falling. The air is so thin up here that there's not enough for the parachute to really have an effect. So for a while it's just going to free fall, and then as it reaches lower altitudes, the air pressure will be higher and the density will be higher for the parachute to make more of an impact. And here you can kind of see that the payload compartment is now like hanging and spinning. It's not so much just free falling anymore because the parachute is actually holding it up. In this view here, we're much lower now to the ground. You can see these are the Florida mountains off in the distance. And our landing zone is going to be down in this general area here. So here we are coming down, and here you can see that road, or a road similar to the one that we saw on the map. And as you can see, it's barely even a road. So here we come in for our landing, and rather miraculously, the payload compartment hit the ground, did a flip, and landed back on its bottom, so that, you know, it was standing right side up. So when we did the payload recovery, there's the Florida mountains off in the distance. We had to drive off-road, a very short distance. You know, there were dirt roads, and then we kind of walked around in the general direction that we thought it was going to be in based on the prediction, and we happened to see that red parachute and walked up to our payload just kind of sitting there. It's really cool. So, with those resources in mind and all of that information, I hope that it inspires you to try out a high altitude balloon mission of your own. If you have any questions whatsoever about any of the items on this checklist or any of the resources that I used in this video, please feel free to reach out to me. I'd be happy to answer any questions that I can.